And okay, well, thanks very much for the introduction. Just to very quickly overview the catchments program. As Tim mentioned, we're in operation a little over 10 years. We're funded by the Department of Agriculture, Food and the Marine. And one of our main functions is to evaluate the nitrates directive and the derogation to the 170 organic stocking rate limit. Okay. And to do that, at the outset, we spent quite a bit of effort in picking out 6 different catchment areas. They weren't picked at random. We'll stay on that slide. On a little bit quick. They weren't picked at random. Can you go back to the slide and contrasting catchments? Back a slide.
It's just slow to react, Eddie. I'm going back.
Yeah. There. Yeah.
Sorry, Eddie, just 1 or 2 people that depending on your connection, the slides might not show for everybody. If anybody's not seeing the slides, maybe just put a little note in the chat. We're not sure if we can do anything about it, but it'd be good just to know how big a problem it is. But drive on now.
So
go ahead, Eddie. Yeah.
As Jenny explained there, that the contrast between nitrogen and phosphorus, the different sites you would expect it to be for different issues. And just very quickly to go through them, starting in the southeast of County Wexford, there's 2 catchments very close to each other. One is on a Clonroach soil type, it's malting barley. It's near Castledockrell or the Ballycarney Inn. 2/3 of that catchment is ploughed every year, and half of it goes for malting barley. And being a free draining soil type, we would have expected phosphorus not to be a problem, and nitrate was expected to be a problem, and it fulfilled that expectation. And again, because it's a tillage catchment, the organic nitrogen loading in that catchment is the lowest of all 6. You can see a figure there of 38 kilograms of organic nitrogen per hectare. And that's not to say it's not intense. It's to say that there's a lot of tillage there and not livestock. Very close by, we have a heavy clay soil type catchment. It's on a Macklemore soil type near Ballycanoe. It's close to the coast, and it's predominantly grassland. And because it's a heavy clay soil, we would have expected runoff for the water. The water, when it rains, would run off the surface, and in that scenario, phosphorus is more likely to be an issue and nitrogen isn't. And again, it fulfilled that expectation. Moving on, after that, we went up to County Louth, and it's kind of winter wheat country, potato type ground, and heavyish soil type. And unfortunately, that catchment, both phosphorus and nitrogen is an issue. In Monaghan, we have a drumlin soil type, and drumlin soils are traditionally heavy, and we would have thought that phosphorus would have been a problem. But thankfully there, both the water quality is excellent. Both phosphorus and nitrate levels are low. And in Ballinrobe, in County Mayo, we have a karst limestone catchment with a very shallow depth of soil over the limestone. And because there's not much soil, it was deemed to be phosphorus risky, and it's draining into the lakes in the west, and was chosen for that reason. But again, the water quality is excellent in that catchment, and phosphorus was not a problem. And the final catchment is in Timoleague in West Cork, and it's probably the most intense. It's representative of the most intense dairying that's taking place in the countryside. The vast majority of the farmers there are in dairying and in irrigation, and it's free draining. And then, because it's a free draining catchment, we thought the nitrogen would be high, and it has fulfilled that. Phosphate levels are also elevated in that catchment, and you can see the organic load, or the stocking rate on average across that catchment, is almost 170 kilograms of organic nitrogen per hectare. The rainfall varies from almost 1.5 meters in the Mayo catchment to 900 millimeters in Dunleer in County Louth. And of that total rainfall, you want to remember that about 0.5 meter evaporates and is lost. So it varies. Half of the rainfall flows out a river to 2/3 of it. Okay, we move on. The approach we take when we're studying water quality is we assume that the nutrients have to come from somewhere. So we have a researcher looking at the source of nutrients, and we'll be recording what fertilizer gets applied, what the stocking rates are. And I think when we look at these boxes, source, mobilization, transfer methods, and I'll discuss them, I think we should think of the requirements under the regulations that farmers have to do to try and minimize losses. So the limit on your stocking rate is limiting the source of nutrients. The limit on the amount of fertilizer, P or K, that you can spread is limiting the source of nutrients. So these are source limiting mitigating actions. And they may or may not work depending on the nutrient and circumstance. Then if the nutrient is available, it has to become mobile and get into the water. It might get fixed in the soil. It may be coming from the soil itself. An example of mobilization of nitrogen would be the ploughing up of a permanent sward for reseeding, or old grassland being ploughed up and put into tillage. There is a release of nitrogen in that scenario, quite a significant release of nitrogen. Organic nitrogen, which is fixed, becomes mobile and can be carried in rainwater through the groundwater and eventually end up in springs feeding into a stream. So that's the transfer or the pathway that we're talking about. And again, Jenny showed a comparison between free draining soils and heavier, wetter soils. And again, the pathway there tends to be either on a heavy soil, it's overland flow, or in a free draining soil, you have spring fed streams and rivers. So the transfer pathways are different and the focus is different because of that. Then we're measuring how much nutrient actually leaves in the river, and that's our main piece of equipment in each of our 6 catchments. And we take a sample every 10 minutes, measuring the water quality and the quantity. Jenny also referred to the ecology in the river and in the sea and the growth of algae, and that's the impact of these nutrients. And I think the context of the water course that we're monitoring is important. If we have a river that's flowing into a lake, then the phosphorus could end up depositing in that lake and sitting there waiting until next summer to have an impact. If we have a river draining straight into the sea, there's already plenty of phosphorus in salt water, and if it gets flushed out in a flood and goes out into the sea quite quickly, it may not have an impact. Okay. So that's the approach we take to our research. We'll move on a little bit. So just very quickly, there's some slides explaining and showing what I've been discussing there. I'll move on to the next slide. This is our kiosk, our monitoring piece of equipment. It's a bit like a lab, only it's out in the field. And as I mentioned, it takes a sample every 10 minutes and has been taking a sample every 10 minutes for the last 11 years. And we have 6 of those around. It's replicated, the exact same piece of equipment is replicated across the 6 catchments. And it takes a sample for phosphorus, nitrogen, the turbidity, which gives us a measurement of the sediment in the water, the temperature, pH, conductivity, and total organic carbon. When I started working with the catchments program, this all made sense and I could understand it. And I kind of expected it. The next slide caught me a little bit by surprise. I was taken back by the amount of effort that was put into measuring the volume of water that's leaving the catchment at different times, be it at a low flow during a drought, at normal sort of base flow, or the rivers in a flood. There's huge effort put into measuring how much water is leaving the catchment. Here's an example of someone doing flow gauging in the Timoleague catchment in Cork, measuring the speed of the water, and it can be correlated, or a relationship built up between how much water is leaving the catchment and the height of the river. We have a staff gauge on the side measuring the height, and it can be done visually, and we also have an automated staff gauge. When you put the volume of water together, we can move on to the next slide, with the concentration of the nutrients, when you multiply one by the other, you get the total kilograms of nutrient that's leaving. So just some figures to go through first on our quality standards and the concentration. The phosphorus limit, as Jenny mentioned there, is a very, very low figure. 0.035 milligrams per litre of phosphorus is deemed to be satisfactory from an ecological point of view. That's a very small amount of phosphorus. Next one, the nitrogen. There's a drinking water standard of 11.3 milligrams per litre, and above that, it's deemed to be at risk. There's a blue baby syndrome that high nitrates can give you a problem, give people a problem with. But I think more concern now. All of our 6 catchments are well below the drinking water standard, but we're not below the ecological standard for nitrate, which is required in our estuaries. As Jenny mentioned, nitrogen is the limiting element when you get into salty water, into our estuaries and at sea. And the requirement, depending on the amount of salt, the requirement for nitrate levels in our estuaries is below 2.6. Some of our catchments are above that figure and some are below it. But it's when it actually ends up into the estuary that figure becomes important. So there could be a dilution from other water bodies draining into the same estuary. But they're the 3 figures that are of concern. Now, when we multiply our concentration by the volume of water, we can get the load of nutrient. Moving on. So, and it's really, when I talk about load, we're just talking about the kilograms of nitrogen or the kilograms of phosphorus that's leaving it. And in our catchments are not big. They're about 1,000 hectares in size. And we can divide the total kilograms of phosphorus leaving a catchment by the area and get an average figure per hectare, kilograms per hectare or units per acre that are leaving. And I know I'd like you to try and hazard a guess. What do you think is the kilograms per hectare of phosphorus per year that leaves the catchment, compared with how much phosphorus fertilizer you apply to your farm? I'm not going to delay. We said that the phosphorus concentration figure is very, very low at 0.035. In all 6 catchments, the amount of phosphorus that's leaving our catchment is less than 1 unit per acre. And I would love to say to everyone listening today that next year, I want you all to spread 1 unit of phosphorus less, and our phosphorus problems are going to be solved. That's a source limiting mitigating action. Unfortunately, if you spread 1 unit of phosphorus less next year, it will not make 1 ditty of a difference to the water quality. When you spread it is of much more significance. Okay? And again, Jenny was mentioning on the catchment. So the next few slides hopefully will show that. But we can also break down the load of nutrient into a monthly figure, or we can look at the load of nutrient that's left after a specific rainfall event. I put in, for example, after Storm Ellen this year, we could look and see when the river went into flood, how much nitrogen or phosphorus actually left the catchment area. Just in comparison to the phosphorus figure of less than 1 unit, nitrogen, typical annual loss of nitrogen from our catchments would be between 20 and 40 kilograms of nitrogen per hectare. Okay, next slide. Okay, I have a graph here. Apologies. Sometimes graphs can be a bit confusing, but what I'm trying to show here is the contrast in phosphorus loss between the 2 Wexford catchments. The red dots are the heavy soil type in Ballycanoe, high clay content, in comparison to the Clonroach free draining soil with the black squares. On the bottom axis, moving across the bottom, we see how much water is leaving the catchment in a month. So as we move to the right, the river that we're monitoring is going into flood. If we look at the figure here of around 100, stream flow of 100 millimeters, you can see in the Castledockrell catchment, the amount of phosphorus leaving is around 1 kilogram of phosphorus, sorry, 0.1 kilogram of phosphorus per hectare in that month left. In contrast to 0.4 in the Ballycanoe catchment at the same amount of water leaving. So the heavy clay type soil is much riskier. But I also would like you to note that there's much bigger variety in the phosphorus loss out of Ballycanoe. And what is happening here at the high one is, we generally speaking, would be earlier in the winter when you have a flush out of nutrients off the surface. You get high concentrations and high loads of phosphorus leaving in a flood. But later in the year, when the phosphorus isn't there, the amount being lost is less. So there is a big variety. So there is a huge contrast here between the two catchments. And to add to that, we'll click again, a bit of animation here. The soil results show that there's much greater levels of phosphorus in Castledockrell than there is in Ballykinnew. And also the amount of chemical fertilizer being applied in Castledockrell significantly higher, 2 to 3 times higher than what has been applied in Ballykinnew. So we'll move on. Really, the point I'm trying to make is that the pathway, whether it's overland versus groundwater, is much more significant than the source of nutrient. And as I've said, there is a huge variation within a year, particularly in the heavy soil catchment. So with that in mind, when you're putting in place actions to try and minimize phosphorus loss, we don't apply the same rules in everywhere. We want to try and apply rules that are site specific. Next slide is kind of just building on that. We're looking at the Castledockrell catchment. Again, it's a free draining catchment. We'd expect phosphorus not to be a problem. And we're comparing 2 heavy rainfall events, one in summer. Click down a couple of times. I've animation there that I should really have taken out. So in the summer event, the soil was quite dry. You can just hold it there now. And there was soil moisture deficit of 31 millimeters in comparison to the winter event when the soil was saturated. And there was no capacity to flow up into the rainfall. It rained about an inch each time. In the summer event, the stream didn't change a whole lot. Only a small amount of that water ended up in the stream. And 1.6 kilograms of phosphorus per hectare was washed after that heavy rainfall event. In comparison to the winter, there was 6.5 grams of phosphorus was lost. So there was 4 times the P loss after the winter rainfall event. And so this is leading to why we have a closed period for spreading of fertilizers. Okay, next slide. Just further emphasizing that there was a particularly heavy rainfall event in 2014, particularly heavy storm. 2 heavy bursts of rain came within 24 hours of each other, and the river went into flood. Now, the phosphorus catchment, the Castledockrell catchment is usually very low with a phosphorus runoff. We don't consider it to be P risky. Okay? Click there to bring up a graph. I have a graph showing the flow of water that's leaving the catchment, and you see the river went into flood up and down quite quickly within a 24-hour period, and the amount of phosphorus that left within 24 hours, click again, was equal to what would normally leave in 1 year. The average annual loss of phosphorus left after that heavy rainfall event in Castledockrell within a 24-hour period. And unfortunately, we seem to be getting more and more extreme weather events like this. And we need to be aware of that when we're trying to minimize losses. Okay. Moving on to nitrogen. Oh, sorry, but before we move on to nitrogen, all the slides, you can move on to that slide. All the losses I've been talking about there are kind of like big bursts of phosphorus. And I mentioned if that flushes out and the river goes into flood and the phosphorus comes into it and gets washed out quite quickly and it goes out into the sea, it may not have a massive ecological impact. If it's flown into a lake, it's very significant because it'll sit there in the lake until next summer when temperatures pick up and daylight gets longer and we will have an algae bloom in the lake like what Jenny's slides were showing earlier. But in our rivers, if we have a constant trickle of a low amount of phosphorus coming into it, that can have a very significant impact on the ecology in our riverbed. So I'm not talking about the same amount of phosphorus here, but it's more the fact that it's coming in constantly, day after day, If there's a low amount coming in there, and particularly during the summer months when rivers are in low flow, this can have a very detrimental effect. So we need to be conscious of these things, and typically things like this I'll be considering septic tanks or wastewater treatment facilities that are working constantly regardless of the weather. Okay. So we need to be aware of where the river is flowing into when we're trying to think of the ecological impact. So moving on to nitrogen. The drought in 2018 had a fairly major impact. Our soils, this is the Dunleer catchment in County Louth, and the blue line is the nitrate level in 2017. In 2018, it was somewhat similar until the end of the drought, and when it began to rain again, the nitrate levels jumped. And they jumped in all 6 catchments to levels really that we had never seen before. We'll go on to the next slide. Can we move on? Okay, so this is the Ballycanoe catchment, and you can see the nitrate levels in Ballycanoe, generally speaking, are just above 2 to 2.5. But in 2018, they jumped up to a figure of 13.6 milligrams per litre, above the drinking water standard of 12.3. I can click a couple of times there. So really, what we had here was a massive loss, and over a period, a short number of period after that drought, we had 1.5 times what we normally lose in nitrate after that summer drought. And so the weather is having an impact. Unfortunately, on top of that, the national nitrogen sales in 2018 were greater than what they were in the previous year. And I suppose we need to be aware that if grass isn't growing because, or any crop isn't growing because of a water shortage, adding more nitrogen to it isn't going to resolve that problem. And I think the advice earlier this year would have, when we had a drought in the start of the summer, might have been more tailored to meet that. So this is just an example across all 6 catchments. And you can see the black line is the Castledockrell catchment, which has the lowest proportion in the derogation, and yet that catchment has the highest nitrate level. That's followed by the Timoleague catchment, which is also free draining, and is intense from an organic loading. So just really what I'm saying there is that the soil type is a very significant influence on the nitrate that's been lost to the watercourses, but there is also a significant weather effect. We can just skip down a couple of slides there now, because I think my time is up, and I just want to go to one that says summary at the end of it. To an end, and I hope I leave those slides now open to discussion. If you can just move on to really where I say summary. Yeah. You can move up. You could skip these ones. Okay, actually, just the reason why, sorry, on that slide there, the reason why the nitrate is different is as the nitrate is carried by groundwater through the soil, the soil has the ability to remove nitrate if it's waterlogged. If there's no air in the soil, there are bacteria that grow in conditions where you have no air, like in a silage pit when you seal it. There's special bacteria in soil when you have waterlogged conditions. There's bacteria that will feed on the nitrate and will release it. There's a denitrifying bacteria, and they will release the nitrate into the atmosphere. And that's why in freer draining catchments, these conditions are not as likely. In a heavier soil catchment like in Ballycanoe, they're more common, and consequently we've lower nitrate levels. So really what I'm saying there is the nitrate that ends up in the river does not always reflect the intensity. It's more likely to do that in freer drain catchments. So in summary, again, I think I'm repeating a little bit on Jenny's here, but the ecological status is a very key a factor under the Water Framework Directive requirement. We're reaching the end of the cycle Water Framework Directive, Nitrates Directive coincide in 2021. And the trends are going in the wrong direction, and the river water quality has been highlighted in recent years as going in the wrong direction. That's a phosphorus and sediment issue that's impacting on the ecology. And with that in mind, we want to be aware of both the constant trickle coming into it and big flush outs. Nitrogen and phosphorus are hugely contrasting. They're contrasting in where they come from. Free draining soils versus heavier soils. And again, that's how they're, is it surface runoff or spring fed, and where they have an impact. So really the point I'm making there is if we put in a lot of effort to reduce the nitrogen emission into the water, that may not have an impact in our river water quality, because the ecology in the river, the boats that live in a riverbed are being impacted by sediment and phosphorus, not by nitrogen. Thanks very much.